Welcome back to my YouTube channel. In this video I want us to learn on writing electronic configuration of atoms. So how do we write the electronic configuration of atoms? Okay, so before you write the electronic configuration of atoms, you need to know about orbitals. You need to know what are orbitals. So orbitals, these are sub energy levels, the subshells of which shows the location of electrons and the energy levels of atoms. So the orbitals, they are just subshells. We have shells, now the subshells of which shows the location of electrons. Okay, so we have four types of orbitals. We have the s orbital, which can only accommodate the s orbital, which can only accommodate 2 electrons. Okay, sorry about the noise, there's a baby in the neighborhood. Okay, so apart from the s orbital, we have the p orbital. We have the p orbital, which can accommodate, now the p orbital has about 3 suborbitals. So the p orbital has 3 suborbitals, which each contain 2 electrons. Okay, so which means that in this case, in the p orbital can accommodate about 6 electrons. So the p orbital contains 3 suborbitals which contain which can accommodate 6 electrons. Okay, then we have the d orbital. We have the d orbital. The d orbitals has 5 suborbitals. The d orbitals have 5 suborbitals. Now these suborbitals can also accommodate 2 electrons each, which makes it that it can accommodate 10 electrons altogether. So the d orbitals can accommodate about 10 electrons. Then the last one, which is the f orbital. The f orbitals has about 7 suborbitals. It has about 7 suborbitals. So now these 7 suborbitals each contain 2 electrons, which makes it to have the ability to accommodate 14 electrons. So the f orbital can accommodate 14 electrons. Okay, now once we know about these orbitals, the s orbital, the p orbital, the d orbital, and the f orbital, now you need to learn how to arrange these orbitals. What happens to these orbitals? Where exactly are they found? Okay, now first I'm going to use the letter n to represent the position of the shell number. If you remember, when we draw the electronic structure, we have the shell number 1, shell number 2, shell number 3, just like that. So when n is equals to 1, it has only one orbital, which is the 1s orbital, which can accommodate 2 electrons. So when n is equals to 1, then it only contains one suborbital. Then when n is equals to 2, this contains 2 orbitals. It has the 2s orbital and the 2p orbital. When n is equals to 3, it has 3 orbitals, the 3 subshells. So we have the 2s, we have the 2p, and the 2d subshells. Okay, then when n is equals to 4, when n is equals to 4, it has 4 subshells. It has the 2s, it has the 2p, it has the 2d, and the 2f. Okay, so these are trends which you have to know. This is the procedure which you have to know for you to be able to arrange the subshells or the orbitals in order. Now we are saying that the s orbital can accommodate 2 electrons. All these subshells, all these s orbitals can have 2 electrons. This one can accommodate 2, this can accommodate 2, so all the s orbital can accommodate 2 electrons. The 2p or let me say the p orbital can accommodate 6 electrons, the d 10, and the f can accommodate 14 electrons. This this sketch which is here is very important when writing the electronic configuration of atoms. Okay. Now let me teach you on how to write the electronic configuration of calcium. The electronic configuration of calcium, Ca, mass number 40, atomic number 20. Now when writing the electron configuration, we use the number at the bottom, which is a proton number. Why are we using the proton number? The number of protons is equivalent to the number of electrons in neutral atoms. Okay, so we're using the number at the bottom there. Now for you to write it easy, it's very important to have this on on the side, on the end, at the end of the page. So we have the 1s, we have the 2s, we have the 2p, we have the 3s, 3p, 3d, then we also have the 4s, 4p, 4d, and the 4f. Okay, we have these can have 2, these can have 6, these can have 10, and these can have 14. Okay, so in calcium we have 20 electrons altogether. So this 1s is the first subshell in a calcium atom. We are giving an example on calcium atom. So you write 1s. Now this 1s, we are saying that s can accommodate 2 electrons. So this becomes 2 there. So this one is gone. Okay, then we go to this one here. So the 2s orbital. The 2s orbital, remember the s orbitals can only accommodate 2 electrons. So we also write 2. 2 plus 2, we have 4. Out of 20, we remain with the 16. Okay, we move on. We also those 2. So from the 2s orbital, we're going to the 2p orbital. So these arrows, they're showing you the order of writing these orbitals. Okay, so we have the 2p orbital. Now the p orbital can accommodate 6 electrons. Altogether we have 10. We have remained with 10 that side. From the 2p, we go to 3s orbital. So we have 3s orbital, which can also have 2 electrons. So if you need to be counting the electrons so that you don't miss it out. So 2 plus 2 is 4, plus 6, which is 10, then plus 2, which is giving you the 12, will remain with 8. Now from the 3s orbital, we go to the next part here. We have 3p comes first, so we write the 3p. Okay, let me write it down here. We have 1 s2 there, we have 2 s2 there, we have 2 p6 there, we have 3 s2 there. Okay, we are from writing the 3s orbital. Now we are going to the other part, starting with the 3p. Remember, I'm saying that these arrows are showing you the the order of writing these suborbitals. So 3p comes first, so we have 3p. P we know can accommodate about 6 electrons, but remember up to here we have 12, remain with 8. Okay, so we put the 6 there to make it 18. From the 3p we go to the 4s. So next is 4s orbital. S can accommodate 2 electrons. When we add these, are we getting the 20? Okay, yes, we're getting the 20. So this is the electronic configuration of calcium atom. Okay, let's also look at the second example. Oh, I shouldn't have rubbed that. Let's say sodium 1123. As usual, this is the proton number, so we're using 11. Okay, we have the 1s, we have the 2s, 2p, we have the 3s, 3p, 3D, we have the 4s, 4p, 4d, and 4f. Okay, so sodium has 11 electrons, so we have the 1s, which can accommodate 2 electrons. Good. Then we're done with that. Next we have the 2s, which can also accommodate 2 electrons. 2 plus 2 is 4, so you should be adding, because the total number should be 11. Then from there we have that, so we have the 2p orbital. So the 2p orbital can accommodate 6 electrons. You need to be adding, so in this case we have 4 plus 6, which is 10. Next we have the 3s orbital. The 3s orbital, we know that it can accommodate 2 electrons. Now we are just not supposed to write what we know that it can have 2 electrons. Remember, we are counting these here. Okay, so altogether when you add these, they should give us 11. So now look at this. When you add these, 2 plus 2 is 4, plus 6, which is 10, plus this is giving us a 12. So this becomes wrong. So instead of writing a 2, we just have to write the number of electrons remaining, which is 1 in this case. So this is the electronic structure for sodium. Okay, thank you so much for watching, but I want you to to write the electronic structure for magnesium. Magnesium has 12, 24 there. Then also for oxygen 8 and 16. Thank you so much for watching. Have a blessed day.